Okay, I'm pasting quiz link in the chat window. People who have joined late can complete the quiz. Good afternoon.
Good afternoon.
Good afternoon. So today, fifth module I would like to complete. So I'll wait for 1 or 2 minutes. Let your friends join. Okay, so we'll start. So we've started with fifth module. So the fifth and last module is the transaction module. So what is the transaction module is doing? How the database transaction should be done. If it is fine. Okay, so here, module 5, the transaction management overview. So this is what the chapter we have started, the last unit of this your DBMS chapter, and we have started with how the transaction behind in the database is going on. Just we say transfer 500 rupees from an account A to account B. This is only one sentence in English, but imagine in the database how many transactions we have to do. That's what A's account to B's account, how many are there. First, you have to see where the A is, account A is, the address of that, then read what is the balance, then subtract from A. Then when you're subtracting 500 and the balance will be changed, so update that balance, then close. So this is just for one transaction, taking on a value from A, then transfer that to B account. So that's what your B account will be doing. So then we have seen about the ACID property. A transaction is a very small unit of a program, and it may contain several lower level tasks. A transaction in a database system must maintain atomicity, consistency, isolation, and durability, commonly known as ACID properties, which we have seen, in order to ensure accuracy, completeness, and data integrity. So then what is atomicity? Where either you complete the transaction or please don't complete the transaction. Then what is consistency? Any number of users use the database, but still it should be in a consistent state. Then what is durability? Maybe your database is not only for 1 year, it may be years together. Still the database should work fine. That's what the durability is. Isolation. So now we are using 1 lakh people are using the database, but still one person's transaction should be isolated or should not be mixed with some other person. That's what the isolation is. Serializability, one after the other we have to do. Then schedule. So how is your timetable scheduled for this particular time to this particular time? So that is what the schedule is. So then serial schedule, one after the other, the order is there. Like now we call your USN numbers. So then now first Asta will respond to us. Then that's what order is being maintained in a serial schedule. So in a multi-transaction environment, serial schedule are considered as a benchmark. The execution sequence of an instruction in a transaction cannot be changed but two transactions have their instruction executed in a random fashion. This execution does not harm if two transactions are mutually independent and not working on a different segment of data. But in case these two transactions are working on a same data, then the results may vary. This every varying result may bring the database to an inconsistent state. So to resolve this problem, we allow a parallel execution of transaction schedule if its transactions are either serializable or have some equivalence relation among them. So then we have seen about the equivalence schedule. An equivalence schedule can be of following type. So the result equivalence, if two schedules produce the same result after execution, they are said to be result equivalent. They may yield the same result for some value and different results for another set of values. That's why this equivalence is not generally considered significant. So view equivalence, two schedules could be view equivalence if the transaction in both the schedules perform similar action in a similar manner. For example, if T1 reads the initial data in S1, then it also reads the initial data in S2. If T1 reads the value written by J in S1, then it also reads the value written by J in S2. The equivalence, view equivalence. Then conflict equivalence, two schedules could be conflicting if they have the following properties. Both belong to separate transaction, both access the same data item. So that is what conflict equivalence is. Then we have seen about a state of transaction. So whether it is active state or partially committed or failed. Then we have seen about aborted and committed. Aborted means stop, restart the transaction or kill the transaction. So whether in between there were some error, then restart the transaction or kill the transaction. Then committed, if a transaction executes all its operations successfully, it is said to be committed. All its effects are now permanently established on the database system. So concurrency control, if a multi-programming environment where multiple transactions can be executed simultaneously, it is highly important to control the concurrency of transaction. We have concurrency control protocol to ensure atomicity, isolation, and serializability of concurrent transaction. Then we have seen about locking. So because when the same resource is required for 3 people, the resource cannot be broken and given to 3 people. Instead of that, what is the solution is 3 people can be using each person 1 hour. So that's what the concept here. Use 2 concepts are used here. That is lock-based protocol and a timestamp-based protocol. What is lock-based protocol is once if the resource is assigned to one person, that person can lock it and no others can use that particular resource. Once he releases the lock, next person can use it. So this concept is called as a lock-based protocol. Then same way timestamp-based protocol, time. So time will be given. So the resource for you is given for 1 hour. After 1 hour, you have to release that resource. That is what is called as a timestamp-based protocol. So again, in lock-based protocol, database system is required for a locking. Then in the locking, we have a binary lock and a shared lock. What is binary lock? Either you lock it or unlock it. Shared or exclusive. This type of locking mechanism differentiate the lock based on their uses. So there are 4 types of lock protocols available. That is simplicity lock protocol. Simplicity lock-based protocols allow transaction to obtain a lock on every object before write operation is performed. Transaction may unlock the data item after completing the write operation. So pre-claiming lock protocol. Pre-claiming protocol evaluate their operations and create a list of data item on which they need locks. Before initiating an execution, the transaction requests the system for all the locks it needs beforehand. So if all the locks are granted, the transaction executes and releases all the locks when all its operations are over. If all the locks are not guaranteed, the transaction rolls back and wait until all the locks are guaranteed. This locking protocol divides the execution phase of the transaction into 3 phases. In the first part, when the transaction starts executing, it seeks permission for the lock it requires. The second part is where the transaction acquires all the locks. As soon as the transaction releases its first lock, the third phase starts. In this phase, the transaction cannot demand any new lock. It only releases the lock required. So then we have a two-phase locking thing, where one is called as a growing, when all the locks are being acquired by the transaction, and the second phase is shrinking, where the locking held by the transaction are being released. Growing, you can take the lock. Shrinking, you can release the lock. That is what two phases, grow and shrink. So to claim an exclusive write lock, a transaction must first acquire a shared read lock and then upgrade it to an exclusive lock. Strict two-phase locking. The first phase of strict 2PL is same as 2PL. After acquiring all the locks in the first phase, the transaction continues to execute normally. But in contrast to 2PL, strict 2PL does not release a lock after using it. Strict 2PL holds all the locks until the commit point and releases all the locks at the time. So then strict 2PL does not have cascading abort as 2PL does. So timestamp based protocol, the mostly commonly used concurrency control is a timestamp based protocol. This protocol uses either system time or a logical counter as a timestamp. Locking based protocol manages the order between the conflicting pairs among transactions at the time of execution, whereas timestamp based protocol start working as soon as the transaction is created. So every transaction has a timestamp associated with it, and the ordering is determined by the age of the transaction. A transaction created at 002 at some time log. So here in this example, we have taken 2 o'clock, could be an older than other transaction that comes after it. After 2 o'clock, whatever the transaction is being done, that will be older. In addition, every data item is given at least read and write timestamp. This lets the system known when the last read and write operation was performed on the data item. Timestamp ordering protocol. The timestamp ordering protocol ensures serializability among transactions in their conflicts, read and write operation. This is the responsibility of the protocol system, that the conflicting pair of tasks should be executed according to the timestamp values of the transaction. The timestamp of the transaction Ti is denoted as Ts of Ti. A read timestamp of data item X is denoted by R timestamp X. So write timestamp of data item X is denoted by W timestamp X. So if a transaction Ti issues a read X operation, if Ti is less than if timestamp of transaction Ti is less than W timestamp of X, the operation is rejected. If timestamp of Ti, that is Ti is a transaction, is greater than or equal to timestamp of X, operation executed. All data item, excuse me. All data item timestamps updated. If a transaction Ti issues a write X operation, if Ti less than R timestamp X, operation rejected. If Ts of Ti less than W timestamp of X, the operation rejected and Ti rolled back. Otherwise, operation is executed. So we will start with Thom's right rule. So what is this Thom's right rule? This rule states that if timestamp of Ti, any transaction Ti, is less than write time of timestamp X, then the operation is rejected and Ti is rolled back. Now, the timestamp ordering rules can be modified to make the schedule view as serializable. Instead of making Ti rolled back, the write operation itself is ignored. So in a multi-processing system, deadlock is an unwanted situation. So deadlock is what many people are using, but we don't know who will use that resource. So in that case, we have a which you have studied in the operating system. Same way, even in the database also, we have something called as a deadlock. Deadlock is an unwanted situation that arises in a shared resource environment where a process indefinitely waits for a resource that is held by another process. For example, assume a set of transaction T0, T1, T2, etc. Tn. T0 needs a resource X to complete its task. Resource X is held by T1 and T1 is waiting for resource Y, which is held by T2. T2 is waiting for resource Z, which is held by T0. Thus, all the processes wait for each other to release resource. In this situation, none of the process can finish their task. This situation is known as a deadlock. So now deadlocks are not healthy for a system. So deadlock, I think you'll be knowing what is a deadlock. Deadlock means if one resource wanted by the two people, and two people are waiting for that resource. One people is thinking that he is taking, another people is thinking that he will be taking. Like this thing is called as a deadlock. So deadlock in any system is not healthy. In case it is stuck in a deadlock, the transaction involved in the deadlock are either rolled back or restarted. So then deadlock prevention, how to prevent this? To prevent any deadlock situation in the system, the DBMS aggressively inspects all the operations where transactions are about to execute. The DBMS inspects the operations and analyze if they can create a deadlock situation. If it finds that a deadlock situation might occur, then that transaction is neither allowed to be executed. That's what a deadlock prevention is. So there are deadlock prevention schemes that use a timestamp ordering mechanism of transactions in order to predetermine a deadlock situation. So that is wait or die scheme. In this scheme, a transaction request to lock a resource data item which is already held with a conflicting lock by another transaction. The none of the two possibilities may occur. So there may be two options. That is, if timestamp of Ti is less than timestamp of Tj, that is Ti which is requesting the conflicting lock is older than Tj, then Ti is allowed to wait until the data item is available. This is first option. One more option, if timestamp of Ti, that is transaction Ti, is greater than timestamp of Tj, then Ti is younger than Tj. Then Ti dies. Ti is restarted later when with a random delay but with the same timestamp. This scheme allows the older transaction to wait but kills the younger one. So would wait scheme. In this scheme, if a transaction requests to lock a resource data item which is already held with conflicting lock by some other transaction, one of the two possibilities may occur. If a timestamp of Ti is less than timestamp of Tj, then Ti forces Tj to be rolled back. That is, Ti wounds Tj, Tj is restarted later with a random delay but with the same timestamp. So if Ti timestamp of Ti greater than timestamp of Tj, then Ti is forced to wait until the resource is available. This scheme allows the younger transaction to wait, but when an older transaction requests an item held by a younger one, the older transaction forces the younger one to abort and release the item. In both the cases, the transaction that enters the system at a later stage is aborted. What is deadlock avoidance? Aborting a transaction is not always a practical approach. Instead, avoid a deadlock is a better way. So, a deadlock avoidance mechanism can be used to detect any deadlock situation in advance. Methods like wait for graph are available, but they are suitable only for those systems where the transactions are lightweight, having fewer instances of resource. If in a bulky system, deadlock prevention technique may work well. So that's what you can see here. Wait for a graph. Wait for the lock. So Ti is waiting for Tj to release the lock, and Tj is waiting for Ti to release the lock. So this graph, wait for graph, will at least avoid the deadlock. This is a simple method available to track if any deadlock situation may arise. For each transaction entering it to the system, a node is created. When a transaction Ti requests for a lock on an item, say X, which is held by some other transaction Tj, a directed edge is created from Ti to Tj. If Ti releases item X, the edge between the misdropped and Ti locks the data item. The system maintains this wait for graph for every transaction waiting for some data item held by others. The system keeps checking if there is any cycle in the graph. Here we can use any of the two following approach. First, do not allow any request for an item which is already locked by another transaction. This is not always feasible and may cause starvation, where the transaction indefinitely waits for a data item and can never acquire it. So this is the first approach where the deadlocks can be done. One second. Okay. So these are the two approaches where these condition is to roll back one of the transaction. It is not always feasible to roll back. The younger transaction, a SIT may be important than the older one. With the help of some relative algorithm, a transaction is chosen, which is to be aborted. The transaction is known as a victim, and the process is also known as a victim section. So this is how we try to solve the deadlock. So this completes your fifth module. Any doubts? Any doubts regarding the fifth module? Please feel free to ask me. Any doubts? Yes, any doubts you can ask me. Yes, any doubts? Any doubts? Yes, just let me summarize and close this chapter. And this is the end of your fifth unit. So we have started with the syllabus for, let me show you the syllabus and check out whether we have done all the syllabus part or not. Theory syllabus. Okay. So last unit, transaction concept, simple transaction model. So what is the simple transaction model which we have seen? So you can see transaction model and how the transaction is being done. That is what the simple transaction model which we have seen, where A's account and B's account, how to do this. Then the acid properties, we have seen the transaction of acid atomicity, durabilities we have seen. So that is what atomicity, consistency, durability, isolation, and serializability. Along with that, we have seen transaction, isolation, and atomicity. So that's what we have seen. Then transaction isolation level. So what are the isolation levels we have seen? That is what in the isolation levels we have a serializable in schedule. Then serial schedule also we have seen. So then we have started with equivalence schedule. That's what the isolation, it comes under the isolation. Then view equivalence, then conflict equivalence we have seen. Then the state of transaction. So this we have seen. So again, abort and committed. Then we have started with concurrency control. So how is this concurrency control will be done? So in that we have two things. One is a lock based and another one was a timestamp based protocol. So that's what here you can see in the syllabus, lock based protocol. Then we have seen about a lock based, what are the different types of locks, what are the 4 types of protocols available which we have seen. Again, we have seen about a two-phased locking system. One is growing and shrinking. That's what your 2PL stands for, two-phase locking system. And in next, we have seen about a timestamp based 2PL. Then in the same timestamp ordering, we have seen how to order the transactions. Then we have seen about Thomas Wright rule. Then we have started with the deadlock. So in the deadlock, how to recover the system, how to check out, how to handle the deadlock. So deadlock avoidance, deadlock prevention, deadlock in this case, again we have in case if the system fails, failure classification, then how to store them and recover them. And we have seen about a wound weight scheme if the younger one is there, and we have seen these are the two possibilities where the transactions can be handled. Then the younger one, that is what the two ways, whether the transaction is of older one or a new one. So then we have seen about a deadlock avoidance, how to avoid the deadlock. Then we have seen how to check for a wait for graph, and we have seen about the simple method for tracking of the deadlock situation, whether it is arising, whether the system is into a failure or can we recover the system. Then finally, we have seen there were two approaches for lock dead to check out whether the lock is fine, whether can we recover or whether the system is failing. So I have just shown you how the syllabus, what it is there, it is being used. Okay, so this is what your syllabus. So next we move on. We'll just discuss one or two question paper. Okay. The question paper, this is a 5th semester question paper. This was for PE degree. It was the same syllabus. Generally, it will be having same syllabus. The database management system. What are the responsibilities of a DBA and database designer? So what you'll write? So in your first unit, there you have what is a database administrator is doing, and how the database designer, what is a role and responsibility. The list is there in the first unit that you have to write, and based on the marks you have to describe the question. So then next we have a 3 schema architecture, that is low level, middle level, and high level. In that case, we have a conceptual level, logical level, and a physical level. So that you have to draw a diagram and explain them. So then discuss the different types of user-friendly interface and type of types of user who typically use each. So that you have to explain the types of users, that is front end user, back end user. Again, we have a parameterized user, sophisticated user. Those things you have to explain here. Okay, so next one, explain with block diagram the different phases of database design. So you can see there the database design is available, how the SQL, who is let me show you the PPT only and explain you how to explain that. So first module. So in this case, that's what your typical. This is what the three-level architecture schema which they have asked. You have to explain this. So then these are the data users. That is what database administrator and what is a database user is doing. That's what they have asked. These things you have to explain them. And casual users, navy user, parametric user, sophisticated user, and standalone user. So this is what you have to explain with respect to three schema diagram is a responsibility of DBA and database user. And this is different types of user friendly interface and the types of user who typically each one will be doing. So that's what here you can see the sophisticated user, standalone user, and casual and navy user. That you have to write for your third question. And explain with block diagram the different phases of each design, different phases for each design. So what you have to write. So these are the advantages. This is historically conceptual data model. This is a schema diagram, database, three schema architecture. That's what I was saying, external view, conceptual view, and internal view. You have to draw this diagram and explain this. And the architecture, you have to explain all these three. This is what you have to explain for the next question. Draw an ER diagram for a movie database. Assume your own entities. Minimum you should take 4 and attributes and the relationship. So ER diagram. So what we have seen in the ER diagram, one ER diagram unit. So how to draw a ER diagram? This is what a branch. This is not the same but similar one. So this is these are the tables what they have given: branch, student, book, author, and a borrower. And here we have a branch ID, student, book, and author, and a borrower. So then this is what the ER diagram is. So in this ER diagram, you can see branch, student, author, and book. So this is what the ER diagram says to us. This is how you have to write the ER diagram. Similarly, this is cricket tournament where this is a schema diagram, this is a ER diagram. Same way, this was your these are the programs in your lab and their respective schema diagram and ER diagrams. So the same way, the last one, tourist, tourist schema diagram and ER diagram. And the last one was constituency. So this is a schema diagram for constituency, and this is a ER diagram for constituency. Same way, they may ask you any ER diagram. That's what I was saying. You will get one ER diagram compulsory. Here in this case, they have given 8 marks, but for you it may be more. Okay, so then discuss the characteristics of relation. So they have moved on to the next unit, that is Unit 2. So what is Unit 2 says to us? We speak about a relation. So in this relation, they're asking about characteristics. So you can see here a formal definition and the characteristics of a relation. So that's what they've asked in this question paper. Discuss the characteristics of a relation. What is the characteristics of a relation? These are the four characteristics of the relation: ordering of tuples in the relation, ordering of attributes in the relation, values and a null in the tuple, then interpretation of the relation in the notation. These are the four characteristics which we have to see in the relation. Then outline the steps to convert the basic ER diagram to relational database schema. So what is the outline we are checking? Outline the steps to convert the basic ER model to a relational database schema. I'll just show you people. So what is ER diagrams? Okay. Then I think it's there in the same end part only. This chapter we have at the end. Come back here. Yeah. So here, so that's what here, the relation database design using for ER to relational mapping. So these steps you have to write. So what are these steps? So ER diagram will be given to you people, something like this. So relational database design using ER to relational map. So these 7 steps are there here. So these steps you have to write step 1, 2, 3, 4 and explain each of them, these things. So these are the seven steps which you have to write for this question. Okay, so define the following. You have to define what is relation state, what is relation schema, what is arity, what is domain. So that's about a second chapter. Or they've asked you discuss the various types of set theory operation. So what is set theory operation? Union, intersection, difference, all those which we have seen. So those you have to write here. So that is what the relation operation says to us. That is what the relation algebra thing. So then consider the two tables, show the result of the following. So you would have seen this, the same question I've asked you in your internals, because this was asked in the question paper. So in this table you have the two tables as given. In these two tables, this is what T1 join T2. So left outer join, right outer join, full join and subtraction. So the query is what we have asked. You can see here in this thing, we have seen about transaction update, relation, union, project. So what they've asked, joins, right? Yeah, intersection. Relation algebra operation from a set theory, that is Cartesian product. Relation algebra operation from a set theory, that is a Cartesian product. This is what the binary joins. So joins we have seen. So binary join, example, simple join, equi-join, natural join, binary join, and a relation. So that's what you have to write for these things. Okay, third one, how does SQL implement the entity integrity constraint of a relational model with an example? So what is SQL? So start with the SQL chapter. So in this they have asked you, so how the entity integrity constraint, so all data type, foreign keys, constraints, all these we have seen. So then entity integrity. This is create, alter, drop, simple queries, exit queries, null query, join, aggregate function, entity integrity, where it is, entity integrity. Yeah, somewhere we scroll down. Delete, functions, mapping clause, group clause, ordered by, condition, eliminating, select, queries, table, insert, modification operator, constraints, check constraint, foreign constraint, primary key constraint. So maybe somewhere we have seen. So you have to write regarding integrity constraints. Then discuss shared variables and communication variable. You have to explain about drop command, delete command, and update command. Then write a program segment explains retrieval of tuples with embedded SQL in the C. So we have seen about how to include the SQLs, that is subqueries. So that you have to explain here. Then consider the following. They have given the tables, 3 tables, and they have asked to write a SQL. So works, project name, company name, and salary. In the same way, lives, project name, street, and the city. Located in city, company name, and city. So that's how here list the names of people who work for the company Wipro along with the cities they live in. Find the names of person who do not work for Infosys. So like this, we try to write all the 4 things. 4 list the names of people who work for a company Wipro along with the cities they live in. Find the names of person who do not work for the Infosys. Then find the people whose salary are more than that of all the Oracle employees. Find the person who works and lives in the same city. So the queries how we have written in the lab as well as in the theory part, same way you have to write the queries for SQL queries for these 4. Then we have started with the functional dependency chapter. So in that, what is closure attribute? And we have to write algorithm to find the closure attribute. Then explain the informal quality measures employed in the relation schema diagram. So that's what we have seen with the informal measures, what we take in the functional dependency. So you can see here, that's what here, what is the informal, schematic, redundancy, null value, and surplus. So these are the informal things, guidelines given to us. You have to write these 4. Explain any 2 informal quality measures employed for a relation schema design. So that's what here you have to do, 2 informal quality measures. Then given below are 2 sets of functional dependency. They are given a relation where in this relation, how many columns are there? Column A, B, C, D, and E. These are the columns. And their functional dependencies are given. That is, A is functionally dependent on B, AB is functionally dependent on C, D is functionally dependent on AC, and D is functionally dependent on E. So then A is functionally dependent on BC and D is functionally dependent on A. So then, what do you mean by multi-value dependency? So explain. This is there for BE people, but if you don't have, so this question is for you out of syllabus. So then consider the following relation, car, and based on this, you have to check whether this is present in the first normal form, second normal form, and third normal form or not. Then this chapter, last chapter, discuss acid properties. What do we mean by acid properties? Acid is, A stands for consistency, atomicity. That's what we have seen in this module. What is this? Acid properties. So acid properties you have to explain. So then what are the anomalies occur due to interleaving execution? So we have 3 anomalies: insert anomaly, delete anomaly, and update anomaly. So these anomalies you have to explain for this question when you are interleaving. Then consider 3 transactions T1, T2, T3, and schedules are given here, S1 and S2, and determine whether each schedule is serializable or not. If schedule is serializable, write the following. Write down the equivalent serial schedule. That is, T1 is there, R1X, R1Z, W1S, R2, something like this, and they have given C1, S1 and S2. So then write whether these 2, S1 and S2, are serializable or not. Describe the problem that occurs when concurrent execution controlled. Give the example. Then just now we have seen what is 2-phase locking. That is, shrinking and allowing. So that's what two-phase, and you have to explain, describe with the help of explain. These two you have to explain 2PL, that is strict protocol locking. Then we have what is deadlock. Then consider the following sequence of action listed in the order they are submitted to be DBMS. Then sequence, we check whether read account A, write account B, read account B. Whether we have to check whether this sequence and we have to check whether it is forming a deadlock or not. And if it is forming, then you have to draw a wait for graph in this case of deadlock situation. I will stop here. We'll continue in the next class. Yes. Meanwhile, I take the attendance. The people who have joined late can complete the quiz window. I'm just pasting the quiz window again. Asta, answer your attendance. Asta. Abhinav. Aishwarya.
Present, ma'am.
Ambrish.
Yes, ma'am.
Anu.
Present, ma'am.
Arbaz. Arjun.
Present, ma'am.
Ashok. Ashok. Benita.
Present, ma'am.
Bhargavi.
Present, ma'am.
Bhavishya.
Present, ma'am.
Chaitra.
Present, ma'am.
Devmalai.
Present, ma'am.
Diksha.
Present, ma'am.
Deepika.
Present, ma'am.
Deepika MB.
Present, ma'am.
Murli Krishna.
Present, ma'am.
Gangubai.
Present, ma'am.
Gujia.
Present, ma'am.
Harshit.
Present, ma'am.
Junjar.
Present, ma'am.
Kavya.
Present, ma'am.
Kishore.
Present, ma'am.
Lata. Lata. Manisha.
Present, ma'am.
Manjunath.
Yes, ma'am.
Nayana.
Present, ma'am.
Nilanjan. Nishant. Pavitra.
Present, ma'am.
Maithili.
Present, ma'am.
Priyanka.
Present, ma'am.
Pavan.
Present, ma'am.
Akash.
Present, ma'am.
Rajeshwari.
Present, ma'am.
Rakesh.
Present, ma'am.
Ramya.
Present, ma'am.
Rashmi.
Present, ma'am.
Ravi. Ravi. Rizwan.
Present, ma'am.
Vishal.
Present, ma'am.
Savita.
Yes, ma'am.
Yesterday, Savita.
I was present, ma'am.
Okay. Shruti.
Present, ma'am.
Sneha.
Yes, ma'am.
Spurti.
Present, ma'am.
Srinidhi.
Present, ma'am.
Srinivas.
Present, ma'am.
Sunil.
Present, ma'am.
Vaishnavi. Vinny.
Ma'am, Lata present, ma'am. 25.
Yeah, marked Lata.
Okay.
Okay, we'll stop here. We'll continue in the tomorrow's class.
Ma'am, TD 22 present, ma'am. Vaishnavi.
Huh? Yeah, Vaishnavi marked.
1 TD.